Hello all, welcome to Code Hub. Consistency is the key to success. So come, let's solve today's LeetCode daily challenge. First, we can read the question. Given a one-indexed array of integers numbers that is already sorted in non-decreasing order. That is, they have given a sorted array. Find two numbers such that they add up to a specific target number. Let these two numbers be numbers of index 1 and numbers of index 2 where the condition is given as follows, and return the indices of two numbers. We have to return the two indices where the number sum to target. And it is one based indexing, so obviously we are going to return the index plus 1 in our answer. And they says that there is an exactly one solution to this problem, and you may not use the same element twice. Okay, and your solution must use only constant extra space. Okay, this is our problem. We can see the example 1 first. The array elements are 2, 7, 11 and 15, and the target is 9. And for this array the target is 9, and the two elements which sum up to the target is 2 and 7, and we will get 9. Okay, what will be the brute force approach here? We can traverse the whole array. For that we will use one for loop, where I will be ranging from 0 to n, and inside which we will be having another for loop where j will be ranging from I plus 1 to n, and we will see if my numbers of I plus numbers of j is giving the target, then we will just return the I plus 1 and j plus 1. This is our brute force solution. For this, the time complexity will be order of n square, where n will be the length of the array, and so this is obviously a brute force solution, and the space complexity will be order of 1, since we don't use any extra space here. Okay, how we can optimize this? Okay, since they have said that the array is sorted, we can take advantage of that point. We can consider 2, 7, 11 and 15. Let's say the two elements, if we sum up, we get either a greater element than the target or a lesser element than the target, or the elements itself give a sum of the target. Like 7 plus 11 is 18, and 18 is greater than 9, and 2 plus 11 is 13, 13 is greater than 9, and 15 plus 2 is 17, 17 is greater than 9. So keeping that point in mind, since the array is sorted, we can have a low pointer at 0th index and a high pointer. We will use a 2-pointer technique here, and then a high pointer at the last index of the array, and we can check whether the sum is equal to the target. If the sum is greater than target, we can just decrement the high pointer, so that the next time when we add the elements from the low and high index, we will get either a sum is greater than the target or lesser than the target. And if we get a sum which is less than target, we will just increment low pointer, so that we will get either we will get a sum which is greater than target or which is almost equal to the target. So that's the idea of this approach. We'll do a dry run here. We'll have a low pointer at 0th index, and high pointer at size minus 1th index, which is 3, 0, 0, 1, 2 and 3. So the sum at 0th index and sum of the elements at 0th index and 3 index is 2 plus 15, which is 17. Since 17 is greater than 9, target is 9, right? So 17 is greater than 9, we can just decrement the high pointer. So low is 0 now and high is 2 since it is decremented by 1. And now we will see the sum again. Sum is the element at 0th index is 2 and the element at 2nd index is 11, and which gives a sum of 13, which is greater than 9 again, which is greater than target again. So we will decrement the high pointer. High pointer is 1 now, and you can see 2 plus 7, which is the target now, which is equal to my target. So we will return low plus 1 and high plus 1, and this will be the dry run. Yeah. And what will be the time complexity for this approach? Here we will run at most order of n time. So the time complexity will be order of n, where n will be the length of the array and space complexity will be order of 1. And we have satisfied the condition also. We must use the constant extra space. So we have used a constant extra space, and this is an optimized approach. Okay, now let's code the approach now. We'll declare a answer array. No, instead of declaring, we are just returning only the true index if it is there, so we can return directly. So we need a low pointer which is initialized to 0 and then high pointer which is initialized to numbers dot size minus 1, the last index, numbers dot size minus 1. Yeah, and we will run this loop for the condition low less than high. What happens if low is equal to high? See, if low is equal to high, we'll be on low is also pointing to same index and high is also pointing to same index, and we'll be having a single element. So we can't sum up single element for target, since they have given a condition that you may not use the same element twice. So we can have the condition as low less than high itself, and we can have a sum variable which is numbers of low plus numbers of high. And what is our condition? If my sum is equal to my target, I have said that we can return low plus 1 and high plus 1. That's it. What if my sum is greater than target? We have seen before that we can just decrement high pointer so that we will get a sum which is less than target or equal to target. Else sum will be less than target only, so we can just increment our low pointer. Since the function should be a non-void function, we will return an empty vector int. Since they have said that there is an exactly one solution existing in this problem, we will end up in this loop itself. So we can just run the code. Okay, we can use example test cases and run the code. Yeah, it passes and we can submit. Superb, it passes the solution, and this is the most optimized approach. And thanks for patience listening.